Hey everyone, and welcome back as we start the second semester. We're going to jump right into Chapter 5, starting with 5.1, the nth roots and rational exponents. We're going to be finding nth roots of numbers. We're going to evaluate expressions with rational exponents and solve some equations using nth roots. But like usual, let's go to a joke of a day. Why wouldn't the shrimp share his treasure? Why wouldn't the shrimp share his treasure? Let's find out. Because he was a little shellfish. Little shellfish there. Kind of like a little selfish shrimp. Alright, enough of that. So let's just jump right in here to the core concept. This core concept you can see right there on your page 125. If you want to go to 125, you can see that. The real nth roots of A. Now I wrote this down up here, and you write that down as well. We have the square root of A, and then the power is, or the root is, n here. Now n is considered to be a root. So this right here, sometimes we can call that right there a root, or we can call it an index. So that's actually what it's saying in your vocabulary, index. That's what that means. The index of the radical is really the root of the radical. And on here it's in real nth roots of A. So there's two types. You can see we got two columns. So one is when n is even, when this number here is an even number, like 2, 4, 6, and so on. Or the other column is when it's an odd number. We're not going to ever see it with a 1, but it could start with a 3, a 5, 7, and so on. So as we go through there, when it's even, here's the characteristics. Sometimes it has no nth roots, no real roots, and sometimes it has one root, sometimes it has two real roots when it's even. So when the A number underneath, when this number underneath the radical is less than 0, which means it's negative. So when that number is negative, we've seen those before, when it's negative there's no real roots, they'd be imaginary. We remember that from back in chapter 3. When A is equal to 0, so when this actually is 0, then we have one real root. That's when they're all even. So if we have a 2 here, a 4 here, a 6 here, goes for all of those. When the A is greater than 0, which means it's a positive number, well, that means it's going to have a plus or minus. As you can see, there's two real roots, two real nth roots, and so we would put a plus or minus in front of that. The other column is odd. So when it's odd, a number odd here like 3 or 5 or something like that, we have when A is less than 0, so when it's negative, when there's a negative there, it does have one real root. So it does have a real root when it's negative. So when we have a negative underneath here and we have an odd number here, we actually can get a real root there, where we can't if it was even. Like if it was a square root or a fourth root, we couldn't. There would be no real roots then. But if it's a cube root, then we could if it's negative. If it equals 0, then it has one real nth root, just like the even ones do. So that's the same as the even ones. When it's greater than 0, when it's a positive number, it has one real nth root. And so that's a little different. This one has 2 when it's even, but it's only 1 when it's odd. Okay, so we need to keep remembering this. This is kind of the big idea that we need to know for the next little section that we're going to do. Okay, so if you turn to page 126 where you see the extra practice, we have exercises 1 through 3. It says find the indicated real nth root of A. So it gives us a number for n, it gives us a number for A, and I just wrote this up here again to remind ourselves that A is the one underneath the radical, n is the root. So we're just going to fill it in here with 3 being our root and negative 125 being the A number. So we're just filling that in like that. So your radical sign, 3 is the root on the outside, negative 125. We would call it the radicand because it's underneath the radical. So we want to just simplify this and actually find what is this real root. So because it's a 3 here and it is a negative, it does have a real root here. This one, because it's negative under here, if it was even, then it wouldn't. But because it's an odd number with 3, we do have a real root. So the cube root of a negative 125, we can also change it to this as well. Here's another thing we're going to get to eventually. We're going to see that this is the same as this. The radicals are the same thing as a fraction exponent. So I want you to start to get a heads up on what we're going to be doing here in the next section. that radicals can become fraction exponents, and this can always be that way, where we have the power on top and the root on the bottom. So our root, the index over here, this 3 is always your denominator of the power here. The 1 is if we had an extra exponent around this. If it had a parenthesis around it and we had some number there, that would be our numerator. But anyway, let's get to the cube root of 125. We know is 5, so it's just going to be negative 5. It's just a negative of that. The cube root of 125 is 5. The cube root of negative 125 is negative 5. All right, let's go a little faster. So I'm actually going to have you try these next two here. So try these next two. If you stop the video really quick, try them and then see if you can get the correct answers for the next two. Okay, hopefully you're back and you've already tried these now and you just plug them in. So you're plugging them in, it looks like this now. It's the square root. We don't actually need to put the 2 here because it's a square root. We can if you want to, and that's not wrong. But the square root of negative 400, well, when negative underneath the root sign, when it's an even root, means it's no real root. So you can change it to that, which you didn't have to. I was just kind of giving you a heads up. But really the thing is, it's a no real root for this one because it's negative under the radical sign with an even root. On the next one, you're going to plug it in. 6 is your root. 6 is the end there. 64 goes underneath. So we can get 2 actually real roots on this one because it's a number here it's positive and it's even there, so it's going to get 2. We can also change that to the fraction exponent. See, always the roots at the bottom, as you can see. 2, the ends at the bottom. And so then this is going to become plus or minus negative 2. So we have a positive and negative on this one because there's 2 real roots, positive 2 or negative 2, just like we saw back when we were taking the square root of something of both sides. Oops. Go with that. Okay, so here was what I was talking about with the rational exponents. Now we're going to see these fraction exponents here, which is the same thing as a radical. We can go back or forth with these. We can take a radical, make it a fraction exponent, but usually what we're doing is taking a fraction exponent and making it a radical. So this is what you want to understand. Here's the main idea and point of this, is that when you see like say right here m and n, the m there is, we would call that the power. So that's the power, and the n at the bottom is our root. So we can always change this now to something like this, where we could see it's got a radical sign where a is underneath. This a is going to always be the one underneath. That's your radicand. The root is here, so we're going to see our root being out here. So that's the denominator. And then we're going to maybe put a parenthesis around this whole thing, and the power would be outside of that. So we might have a power. So the numerator is going to be outside the parentheses, as you can see. So there's your root is n, and your power is m on the outside of the parenthesis. And then we could be able to actually figure it out from there. We can maybe simplify the square root or whatever root that is, and then raise it to this power. If you have a negative power, when we've seen negative exponents in the past, we're just going to flip it, make it a fraction, put this, like basically this is over 1, as you can see. That's what I wrote down here. I want to write that this is over 1. We would flip it so that this becomes a positive now exponent. That's how you change the negative exponent now to being positive down there for that exponent. And then you just do the same thing at the bottom as we were doing here to try to figure that out for the denominator of that fraction. Okay, so back at the extra practice on 126, we're going to go through 4 through 11. We're going to go through this pretty quick. So we're just evaluating the expression without using a calculator. So sometimes we're going to want to use a calculator, and we'll see that kind of at the end. I'll show you where we'll want to use a calculator in some of them. But on these ones, it says don't use a calculator. Do these without a calculator. So starting with this one, we want to change this into a radical. So first put it into the square root. And so we're going to see the square root of the 64. And we want to put the 2 as your root. So I don't actually need to write the 2. Even though you could, but we don't need to write it. And 1 is the power. Well, we don't need to use that when it's a 1. When this is a 1, we don't even need to put parentheses around and put a 1 on the outside. It doesn't affect it. So really, this 64 to the 1/2, it's going to be this. Whenever you have a 1/2 exponent, it's just the square root of that number. That's all it is. And so now we have the square root of 64, which we all should know, hopefully, at this point, is 8. Number 5, doing the same thing. Here's what's going to go underneath the radical. 3 is going to be the root, and again 1, we're not going to need the 1. So it's just going to be a cube root of a negative 27. And we should know what the cube root of 27 is at this point, and since it's negative under here, we do have an answer for this. It's just a negative form of that number. The cube root of 27 we should know is 3, and so the answer is just negative 3, because it's a negative underneath that 27 is negative. If that was positive, this would be positive 3. Number 6, 32 is going to be under the radical sign. We're going to see 5 is our root, going to be on the outside, or in front of this. 7 is going to be the power, so we're actually going to have a parenthesis on this one with 7 being the power, so it'll look like this. Radical sign 32 is underneath. 5 is your root, that's your denominator. Remember, I put this over here, your root's at the bottom, so that's the root. The power is what's on top, 7's on top, so that goes outside here. So we want to figure out, first of all, this fifth root of 32, which we can do that. We can see what the fifth root of 32 is, and that's going to be the number 2. If you multiply 5 2's together, you're going to get 32 eventually. You just keep multiplying 2 times 2 times 2 5 times will give you the number 32. So this is going to be 2 inside here, and then we're going to raise it to the 7th power. So now all this is just 2 to the 7th power. So you got to multiply 2 by itself 7 times. Well, we already know when you multiply it by itself 5 times, you get 32. Well, then we got to multiply that by 2 again, which would give you 64. And then 64 times 2, the last time, would give you 128. And so that's why it's 128. Again, you can try this on your own, verify it with a calculator, but you're supposed to try to do it without a calculator. Now the next one has a negative exponent, which means we're going to need to flip this one upside down, making it into a fraction. This is going to be 1 over this whole thing, and everything's going to be done at the bottom of a fraction. So to make this a positive 3 over 2 exponent, we just put 1 over the whole thing, and now it's a positive 3 over 2 exponent. And everything we do now is just going to be at the bottom. 1's going to remain on the top of our fraction the whole time. So now we're going to see, put that into a radical. 49's underneath. 2 is on the top, and 3 is on the outside. So 2 is your root right here, kind of outside on top, and then 3 is on the outside. That's the power. So the 2 is your root from the denominator, and 3 is the power from that numerator right there. And we could figure out what the square root of 49 is. We should know that. That's 7. And so we can just simplify this now to 7 to the 3rd power underneath here. So 1 over 7 to the 3rd power. And now just multiply 7 times itself 3 times. 7 times 7, when we know it's 49. So 49 times 7 will give us our denominator for this answer. And that's just 343. So there's our answer. All right, so I'm going to let you try these bottom 4. So just like I was doing these, try the same thing on the bottoms. Go ahead and stop the video and try those, and then play it, and then check your answers. Okay, so here's our next one. Negative 32 underneath. You can see 5's on the outside, 3's there. So again, we're seeing 5 to the 32, kind of like that number 6 one. That's going to be a negative 2 inside there. Now we just raise that to the 3rd power. 3 negatives 2's will make a negative 8. So you should have got negative 8 for problem 8. This one, 1,000's underneath. We're going to want to make this, first of all, into a fraction, just like number 7 was. So first make it into a fraction. And as I was doing it into a fraction, I kind of jumped the gun and went straight to that second step. So that's fine if you can do that part in your head. So the square, the radical with 1,000, 3 is going to be outside here, and 2 is going to be outside the parentheses. So the cube root of 1,000, that actually, we should know that to be 10. 10 times 10 times 10. 3 10's multiplied together to give us 1,000. You can see there's 3 zeros in 1,000 for that. And so now it's just 1 over 10 squared, and we know 10 squared is 100, so that should be 1 over 100. And then 81's going to be underneath. Our 4 is our root. Our 3 is going to be our power on the outside. So we're looking to find a 4th root of 81, which we can do that also. So 3 times itself 4 times is 81. So this just is going to become a 3. The 4th root of 81 is a 3. And so that's going to be 3 to the 3rd power now. And we should just multiply 3 times 3 times 3, which is 27. So 3 times 3 is 9, and then 9 times 3 we know is 27. So that gives us a 27 answer. Our last one has a 1 for the power, so we're not going to need parentheses on this one. It's just going to be the 4th root of a 625. That's all that will be. fourth root of 625, and there is a perfect fourth root for 625, and that would just be the number 5. So if you multiply 5 times itself 4 times, that would give you this number 625. Okay, here's a situation where we're going to see that these are not going to be done without a calculator. It says using a calculator on these ones. Now you don't see this. This is not in your notes anywhere. We're just going to watch these and then we're going to try some in your notes. It's like this. So obviously on 9 to the 1/5, if we try to think of this as our root is 5, a fifth root of 9 isn't going to work. We're not going to figure that out. So we're going to use a calculator for that. And so we want to type 9 in, hit the exponent button, and then put a 1/5 in parentheses, 1 divided by 5 in parentheses, and push enter or equals, and we would get that answer. So rounding it to 2 decimal places would give us 1.55. Same thing here on this one. We're not going to be able to figure out the 8th root of a 12, so we just need to use the calculator on this one. So type this one in as 12, then the exponent button, and 3/8 is your exponent, and then enter, and you'll get this decimal, rounding it to 2 decimal places. There you go. And this one's given to us already in a radical form, and so we're trying to figure out the fourth root of 7. Well, that won't work either, so what we could do is put this back into a fraction exponent. So here's where we wind up go from this situation where we're in radical form back to a fraction exponent. As you can see there, we can write it in exponent form, which this is going to be now the powers on top, the roots on the bottom, so it's a 3/4 power. So 7 to the 3/4 power, then you could put that in the calculator and get the decimal of that one. So that's going to be the better way to go. If you're going to put something into the calculator, it's going to be easier to probably put in a fraction exponent. Okay, so let's try some of these. Let's go back to page 123. That's the very beginning of this lesson on 123 there at the top. And we're going to do this first column here, the A, C, and E column without a calculator, and this column will be with the calculator. So you're going to want a calculator there on your phone, or you can use one on the computer. That's right there. I have one, my computer calculator is here. So there it is. But you know, computer calculator or your phone would work just fine. So this side here, we know we're going to use it without a calculator. We can just see it. We can see here that's showing us it means the same thing. The square root of 9 means 9 to a 1/2 exponent, or 9 to 1/2 means the square root of 9. We know the square root of 9. We can do that without a calculator. That's going to be 3 on that one. And I wrote this here just as a reminder that A here is going to be underneath the radical, or it's the base here, and your root's the denominator. On these ones, 1 is going to be the power for every single one, because none of these are in parentheses. So 1 is going to be our numerator of that power. On B, we can try this one. We can see this is becoming 2 to a 1/2, or the square root of 2. We can't figure the square root of 2 out. That's without a calculator. We can't do it. So we go to our calculator and we plug it in. So I'm going to say, and I'm going to put, we can do, the square root of 2, and that would be fine. So on this one, square root of 2 is actually easier. So sometimes, yes, it is actually a little easier to do that. On other ones where it does have the parenthesis on the outside, it is a little more challenging. So for these ones, you might want to just do the roots. But these ones are going to have the cube root and the fourth root on it. So let's, we could try it again with just the 1/2 exponent. So if I said 2, I plug in 2, hit my X to the Y button, that raises up that little arrow like we saw before, and then put in parentheses a 1/2 exponent. So 1 divided by 2. And close the parenthesis, makes it a 0.5, which is just converts it to a decimal there on the screen. And it's the exact same thing as we got before. So that's going to be a 1.41 or a 1.4. I'm just going to put 1.4 on this one as 1 decimal place. So go ahead and stop it and try these next 4 problems. These ones do without the calculator, and try these ones with the calculator and see how you do. And then play it again. Okay, hopefully you tried these already. And let's just go through the answers. So on this one, the cube root of 8 would be 2. Over here, the cube root of 3 on the calculator, that's going to be 3 to the 1/3 exponent. So either way, you should figure out that's about a 1.4, kind of very similar to this one. And then the fourth root of 16, that's also 2. And over here, the fourth root of 12, or 12 to a 1/4 exponent, that's going to be approximately 1.9 on the calculator. Here at the bottom of that page, there's 6 more here to try, so let's try these. Starting with just A right here, we got the square root of 5 to the 3rd power, so let's change that into a fraction exponent. So it's going to be 5 to a 3 over 2 exponent. Okay, so the power, the numerator is here 3, your root is 2 because we don't see it. So if we don't see the root, we just know that number is 2, so 2 is at the bottom. So be careful, you're not going to see a 2 here if they want it to be a square root. So we just got to put this in the calculator now. We would just do this like here. And clear this. We got 5, so put in 5 in your calculator, and I'm going to hit the X to the Y button. That's going to give us our exponent here. I'm going to put an open parenthesis. 3 divided by 2 is my thing here. Now if you want to convert that, and as soon as we close that parenthesis, it converts it to 1.5. If you wanted to convert it yourself, 3 over 2 is 1.5, and just put 1.5 in right away, it'll do the same thing. And then equals gives us our decimal. It's 11.18. So there's our answer on that one. This next one, we can see we're going to make it 4 to a 4 over 2 power. 4 over 2 power on that one. Which actually I'm realizing I just did it wrong. So hang on. Okay, I don't know what I was thinking. I didn't do it wrong. I realized I did it correctly. So here we are with 4. And it's a 2 over 4th power, so 2 is the power on the top, 2 is the numerator, 4 is the denominator at the bottom of this exponent. And we could simplify 2/4 to a 1/2. So if we do that, now it's just 4 to a 1/2, and anytime you see a 1/2 exponent, you know it's a square root. This is just the square root of 4, which we can do in our head. We don't need a calculator for the square root of 4, that's just 2. So go ahead and try, actually I'll do one more and then you can try the bottom. So let's try this one, 9 on the 9. And it's 2/3, so our numerator and our denominator is right there, so that's a 2/3 exponent. And then now this one we will need the calculator for, so use your calculator. 2/3 is actually one that I would not try to convert to a decimal, so it's going to be 9. So 9, and then my exponent, and parenthesis, 2 divided by 3, and then close the parentheses, so you see how that gives me a long list of 6 there. 6 repeating, and then I can hit equals, so 4.32 or something like that, 4.33, what did I put down? Yeah, 4.33, that's how best to round it to. So go ahead and try these last 3 here, D to F, and then play it again and check your answers. Okay, hopefully you stop that and you have D to F done and completed, and let's just check to see if you did this correctly. So it's a 10 to the 4/5 power, and then using the calculator you should be getting approximately 6.31 if you round it to 2 decimal places. E, what's going to be 15 to a 3 over 2 power. There's my 3 got messed up there. It's a 3 over 2 power. Not sure what happened to my 3. Maybe it'll show up here, but do that on the calculator. It's approximately 58.09. And then F there, it's going to be 27. Now this one I'm noticing I could figure out this right here, the cube root of 27 we can do in our head. We don't need a calculator for this one. So the cube root of 27, that's going to be 3, so this is just 3 to the 4th power, and we could figure out that as well without a calculator. That's just 81. Okay, if you turn the page to 124, let's just try these last 6 here that are like these. So I'm going to have you try these on your own. So A and E, I circled those two because those two you can use, you don't need a calculator for. You should be able to do those two without a calculator, but the other ones you're going to need a calculator for. So try these 6 and then start the video, and then I'll show you how to do them and check your answers. Okay, hopefully you've already got your answers now, and let's just go over them. So we shouldn't need a calculator for the first one. That's just going to be the cube root of 8 if I put it back into a radical. Cube root of 8 and then square it. And we know the cube root of 8 is 2, so really that's just going to be 2 squared, which equals 4. So we didn't need a calculator for that one. But B, we're going to need a calculator for. 5 over 2, I can convert that to a decimal if I wanted to. That could be 2.5, and then just put that in the calculator. That might be a little easier. So that's approximately 88.18 on your calculator. C, 12 to the 3/4 power. We can try this and see, is there a 4th root of 12? We're going to be able to do that. And that's how you can kind of know if you need to use a calculator. Is a 4th root of 12? And there's not. Like this one, is there a cube root of 8? And yes, there was. So that's why we were able to do that without the calculator. So this one, we put it in the calculator at 6.45, approximately that. Here's another one. You got the square root of 10. Is 10 a perfect square? No, it's not. So we're going to have to use the calculator for this one. And so that's just going to give us 31.62 as a number. This one is 16 a perfect square. Well, yes, it is. So we can use this one without a calculator. We don't need the calculator because we could figure out what the square root of 16 is. And so we know square root of 16, we know that's 4, and so this is just going to be 4 to the third power. And 4 times 4 times 4, we can multiply that out. It's going to be 16 times 4, which is 64. So that one wasn't too hard to do without a calculator. This one, fifth root of 20, there's no way to get a fifth root of 20 without the calculator. So it's just going to be, we could change 6 to the, or 6/5 to a 1.2 decimal exponent if we wanted to. I'm just showing you can do that, so you can plug in on the calculator a 1.2 instead of 6 divided by 5. And when we do plug it into the calculator, we get approximately 36.41. Okay, we're going to shift gears a little bit here and move over to page 127. There's a little matching one here, match the equivalent expressions on 127. So we would want to just change these into, these over here with fraction exponents. So just using a, so this would be going to be an a is our base, and this is going to be the power on top. So this is a square root, right? So we know it's going to be 3 over 2 on this one. So it's an a to the 3 over 2, which we can match that up with c right there. It's going to say the same thing as c. This one's going to have a negative on the outside. We can see the only one that has negative on the outside is d down there, and this is going to be 1 for the power, and 3 is the root on the bottom. So just a negative a to a 1/3 power, which we could see that is definitely d. And then over here we have a is on the out. A is going to be our base, our big number, or big letter in this case. 2 is the top number, 3 is the bottom number, so 2/3. So a to a 2/3, and we can see that's going to be letter B. And this last one should be the only one with a negative exponent, and that's letter A up there. As we change that and convert that, because this is going to be down here, a to a 1/3, but we won't want to, get this out of the fraction here. We can make this a negative exponent. We can convert it back to a negative exponent, so that's definitely going to give us A. Okay, so now we're going to actually get to solving real solutions of the equations. So we're looking for answers for x. So we're getting to solving equations now, finding real solutions. It says round your answer to 2 decimal places when appropriate. So when we need to use our calculator, we're going to round it to 2 decimal places. So first of all, number 16, I'll probably do these two, and then you should stop the video and then check your answers on maybe 18 and 19. But the first thing we want to do is get this x to the third by itself. Solve for that x. So we're going to divide both sides by 6 first, just like we normally would do if this was normally x. And now we have x to the third is equal to a negative 1. And so now we want to get rid of this exponent of 3. So anytime you're going to get rid of an exponent, you're going to have to do it with a root. So we're going to have to take, in this case, the cube root of both sides, not the square root, because we have a cube here, a third power. So our root also has to have that same power. So when we put this around here, I got to make this a cube root and do the same thing to the other side. So that would now release my x and free the x to be able to just say now x equals, and it equals this cube root of negative 1. We will get an answer for this one because it is a odd exponent here, so we know we're going to get an answer. It's just going to be negative 1. So that's all our answer is going to be on that one. Just one answer, negative 1. On this next one, we want to get this parenthesis by itself. So we need to get rid of our 2 here first and divide by 2. And so that would give us now, canceling our 2's, the parenthesis with x plus 5 to the 4th power is equal to 128 divided by 2. Well, that's going to be 64. And now to get rid of the exponent of 4, we're going to need to take the, do a radical again. Okay, so we got to do a radical with a 4th root. It's got to have a 4 here now. The root's got to be 4 because the exponent is 4 here. That way it undoes that and now releases my x plus 5 from the clutches of the power. And so now it just says x plus 5 is equal to this right here, the 4th root of 64. So now on this one, we're going to get 2 answers. We're going to get a plus or a minus on this one. This is where, when this is a positive number and again an even exponent. It doesn't have to be 2, it could be 4 like this one. We're going to get 2 answers. So the 4th root is 64. So that, we can, see we can multiply something by itself 4 times. If you're not sure, if you've forgotten, then you can just go straight to the calculator and try it. We would know this would be a 1/4 exponent. We could do that even. Put 64 in here, raise it to the 1/4 exponent. That would actually be a 0.25 exponent. Oops, I put 1.4. I put a decimal. I didn't mean to do that. So let's go back and start again. So it would be what, 64, and raise it to, put parentheses, 1 divided by 4. There we go. Close parenthesis. 0.25, like I was saying. And now you can see, well, that's actually not going to come out to an even number, so it's a good thing we used our calculator on this one. Because I'm thinking, well, maybe we can do this on our own, but we actually can't. There is no perfect 4th root of a 64. So use the calculator, and then when you get it out to a nice neat number, then that's good for you. But this one, we have to round it to 2 decimal places. So we're going to make this 2.82 approximately. I think that's what it said there, 2.82. Or 83, let's round it up to 3, I guess. So we'll say this is a 3 at the end, 2.83. And now we just got to subtract 5. So we're going to say, okay, x is equal to -5 plus this 2.83 number. And it's also equal to -5, when we're subtracting 5 from both sides, minus 2.83. And so that's going to give us 2 answers here. So this answer here we're going to get is going to be, it's going to take away 2.83 from -5, leaving us with a -2.18. You can do that on the calculator. And this answer here, it's actually going to add these together and give us a -7.82. Alright, so go ahead and stop the video. Try to solve maybe these two using your roots. Remember, the roots got to be the same as the power. So try to do that on these two, and then check your video. Check it with starting the video again. Alright, so hopefully you tried that, and we can see what we're going to do here. We're going to add 32 to both sides. Hopefully that's what you did, 32. And so you get x to the 5th is equal to, we're going to subtract here. It's going to give us a -32. We got to take the 5th root here. It's got to be the same as that power. 5th root over here as well. And so it's going to give us our x. And the 5th root of -32 is just one answer of -2. And there's our one answer there on that one. This one we start by adding the 100 to both sides, or actually subtracting, 100 from both sides. So -1/10 x to the 3rd is equal to a -100. And now we can multiply both sides by basically -10, or if you want to multiply it by basically the reciprocal of this, we'll get rid of this 1/10. So let's do that. Let's multiply both sides here by the reciprocal of my 1/10. It has to be negative to make sure this is positive, so basically -10. So multiply by -10. So now the 10s would cross cancel right there. And now you're just going to get x to the 3rd. And so that will give us a positive answer over here with 1,000. And now I just need to take, this is a 3rd power here, I need to take the cube root of both sides. So I'm taking the cube root of a 1,000 to get my answer. This releases the x. And on this one we're going to get just one answer because it is the cube root. 3 is only going to have one answer, and it's going to be just 10. So 10 is the answer on that last one right there on number 19. Okay, so this last one, number 20, let's just look at this one. The volume of a cube is 1,728 cubic inches. What are the dimensions of the cube? So we need to know the volume formula for this. That's the first thing we would need to know, that a volume of a cube would just be side cubed. So V equals S cubed. And then we know, well, the V here in this one is 1728. So we can just plug that in. 1728 equals S cubed. And then solve for S. We're talking, what are the dimensions of this cube? We need to find what is the side length of this cube here. So take the cube root now of both sides. So that's what we're going to do here. We're going to take the cube root of both sides and just figure out what's the cube root of this 1728. And we could do that on the calculator, if we want to try that. Now you may want to try it with a cube root. This one actually, here's the cube root button right there on this calculator, but if you didn't have that, you could still do 1/3 exponent like we saw before. So either way would work. So we could say 1728 on this one, hit the cube root button, and it is 12. And it would be the same thing as if we did a 1/3 exponent. So S is 12 inches. So what are the dimensions of the cube? The dimensions are, three things really. It's just going to be 12 inches by 12 inches by 12 inches. That would be considered the dimensions of this. This by this. It's the dimensions of a 2 by 4. That's why it's 2 by 4 on a piece of wood. So 12 by 12 by 12 inches, because all the sides are going to be the same. Okay, I did want to show you this one last problem on page 240 in the book. This is example 5. So there's this one last one here. It's a real life problem that you may need to know and see. Just take a look at this one, read through this one, and kind of see what you would do. It's going to be this formula. They give you the formula here. You just want to plug things into this formula that's going to be up here in our little description. It talks about that the useful life is 10 years, so N would be 10 on this one, so 10 is going to be down there. The machine depreciates at $8,000, so S is going to be depreciation, 8,000. The original cost is 50,000, so C here in this one is 50,000. So you just start putting things in, and you can figure that out. So there's the formula. You plug it into the formula. 1 minus the 8,000 on top over 50,000. 1/10 is your power. You can reduce this number to 4/25, and then take the decimal of that. So now you could say, well, 4 divided by 25. Figure out what this decimal that is, and maybe plug that into the calculator to the 1/10 power, and then 1 minus that. So we can maybe do that on the calculator. We could say, okay, what's 4 divided by 25? That's going to be 0.16. And now raise that with my exponent to a 1/10 power. And so I put 1 divided by 10 inside here, close the parenthesis. That's a 0.1. So equals, gives us this decimal. We would now need to say basically 1 minus that decimal. Let's remember this. It's 0.83. Let's go to 3 decimal places since that's what they want here. 0.833. Let's say 0.833. So 1 minus 0.833, and we should get what they have here exactly, right? 1.167. That's it. That was the answer. All right, so that concludes the lesson for 5.1. You should be ready now to do the assignment for 5.1, so good luck on that.